Hi, let's get started. Good afternoon, everybody. Welcome to another exciting afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. I do have a request. Who's ever dreaming of a white Christmas, stop, it's too early. I woke up and I was doing some stuff. I looked out my window, saw my front lawn covered in snow. It's October. It isn't even Halloween. By the way, that's part of global warming. Global warming is not just hot, it's extremes. And snow in October, that's extreme. All right. I hope you all had a great weekend. I had fun grading tests here and also the other school I teach at. I gave a test end of last week. Some personal news. My back's getting a little bit better, but tomorrow I start physical therapy, and hopefully that will help me loosen up the muscles because they go when I don't want them to go and that's not fun. All right, the joys of growing old. But anyways, first of all, let me tell you, test number 2, you guys did great. Historically, test number 2 has always been the lowest average. You guys are doing good. The class average was 98.7, which is a phenomenal number because normally test number 2 goes way down. Back one semester, I had a 170 class. The test average was 70. They brought it up, but what I'm going to do today is I'm going to be going through the answer key for test number 2. If you did well, think of it as a good review. And if you missed anything, also don't forget to hand in the labs that are due on Wednesday, or lab that's due on Wednesday. And let's get started. By the way, I will be taking this out of the video, but if anybody who's not here needs to see the test answers, please come to my office hours. I'll be more than happy to show it to you. All right, let's get going. It is, what grade am I getting this class right now? Well, it's still pretty early, but there are 2 ways of figuring it out. And let's look at the whiteboard to check those 2 ways out. Thumbs up person, can you see the whiteboard? Thank you. All right. First method. Look at test 1 and 2. The higher score you used, and if that score is 90 and above, you're getting an A, 80, 89, B, 70, 79, C, and 60 to 69 D, and below 60, you're failing. That's method A. Now, method B, like I said, and here, take the sum of your 2 tests divided by 2, you get a number X. If X is 90 and above, you're getting an A. This is in my syllabus, the breakdown, 80 to 89 B, 70 to 79 C, and 60 to 69 D, and below 60 F. And that's how you do it. Like I said, we got lots of points to do. And you all still have time to get a B, and if you work hard, most of you should be able to pull an A. Now, one of the things that's pretty stupid, but they won't see this video, is ECC, and also at COD where I teach does the same thing. It's midterm grades, and we got to enter a midterm grade, which is stupid because there are too many points left to go. Well, I got to put a grade in. Ignore whatever you look at your midterm grade, unless you got real low, but here's how I figured it. Just real quick, I use method B to get your midterm grade. I average your two tests divided by 2, 90 and above. I gave you A for midterm and so on. As far as I know, it means nothing on your record or anything else, but we're required to do that. And part of it is so that college gets federal and state money for your attendance in my class or any other instructor. So I just wanted you to know, I don't know if you'll see midterm grades somewhere on Access ECC or My Access, whatever they call it here, but that's what I did. Any questions? All right. All right, do you see chapter 10 on the screen? Thank you. Talking about esters, did anybody happen to smell the flowers? I don't know if you can, there are no flowers out now, but if you happen to go to a florist shop, you could, and you're smelling esters. Now, if you had a banana, did you smell the ester from the banana and also taste it? Or a pineapple or an apple? Now, if I remember correctly, did I do acid hydrolysis of an ester yet? All you check your notes, help me out. I'm not sure if I ended there or the next one. Oh, let's do this anyways. We got plenty of time. All right. Now, once you have an ester, what can you do with it? Remember, ester, R group, carbonyl, oxygen on the carbonyl, R prime. And if you react it with water and acid hydrolysis with an ester, what happens? You get back the carboxylic acid plus the alcohol you would have used to make that ester. And this is important because this is how your body and your stomach, and I believe it's your small intestine, but don't quote me on the second one. Could be your large one. Excuse me. That's how your body breaks down fats and oils, which you consume in your food, or if you had oil vinaigrette dressing, was in your oil vinaigrette dressing. And let's take a look at how you do this. And remember, and I think I did this already, but practice makes perfect. We're on track. Where do you find acid real quick? In your stomach. And your stomach, the H plus is hydrochloric acid. And you've been drinking water. You're supposed to get your, I don't know, 8, 10 cups of water daily. And that's in your stomach too. And what is the product of this reaction? Well, what's different here? Ooh, carbonyl with an oxygen. You have an ester. And what do you get? You get back the carboxylic acid and the alcohol you would have used to make that ester. So if I look here, this is R prime. I'll have my R group, 2 carbons and a carboxylic acid. And what's R prime? Methyl, and I'll get methanol. And that's how you do acid hydrolysis of an ester. I believe I did this, so I'll just let you try one example. Your turn. What would be the product or product for the following reaction? All right, let's do it. I see everybody's done. And what do we have that's different here? Oh, oxygen, double bond to carbon, same carbon has an oxygen. We have an ester. And we're reacting it with acid and water. And what do we get? We get back the carboxylic acid plus the alcohol we would have used to make that ester. In this case, what's our methyl? What's our prime? Isopropyl with double prime. Hold on. And what do we get? The carboxylic acid would be acetic acid. And my alcohol, the R group, the carbon with the oxygen here, is the carbon with the hydroxyl group here, this middle carbon of 3, and you get isopropyl alcohol. And that's how you do it. I'm pretty sure I did this, so I'm not going to do a synthesis one on here. Oh, I'm not going to cheat you.
When we were looking, or when you asked, I was trying to look through my notes and I was looking at the wrong section. We did do the ester acid hydrolysis and we did the ester base sap conjugation.
I did the base too.
We did that a little bit.
Then you got extra, nothing to be sorry about. One time I went through and nobody told me, I started like 3 reactions I had already done. And finally, you did that already. Why don't you tell me when I was starting?
I mean, it's good review.
Right. Well, that's why I wasn't sure and I didn't have time to look at the video. Bad Dr. White. With that case, something? Now would be a good time to take a 5-minute break so I can stretch my back, come back at 1:50, and then we'll go on to new stuff.
Okay.
And don't get poked in the eye by your cat's tail.
I will try.
One of my worst experiences in life was I dated a woman who had a bunch of cats, and one time I left her place, and somehow I got a cat hair in my eye, and it was the heart. I almost had to go to the emergency room because it took me that long to get it out of there.
Jeez.
It's very irritating. Cats are fun, but you watch out for their hair. Never happened to me with a dog, just a cat once. All right, I'll see you in 5.
Okay.
All right, is everybody back? Glad to see everybody's back. All right, let's continue and I'll start with new stuff. All right, this is new stuff. I don't believe I talked about esters and Gringard. In fact, I know I didn't. All right. Now, let's look at the following reaction. If you take an ester, and there should be a 2 here, organic chemists don't balance it. For PhDs, it's correct. For you guys, there should be a 2 there. If you take an ester, a reactor with 2 molecules of a Grignard, second step, acid and water. What happens? Keep your eye on the carbonyl carbon. The R group is still attached to it. Now you make not 1, but 2 carbon-carbon single bonds, and the carbon with the carbonyl becomes an alcohol. This right here also becomes an alcohol. And in real life, you keep R real small so you can distill this off, and you can make a very complex alcohol here. Now, how does this happen? Now, Dr. White's going to have some fun with a mechanism. What I'm going to write, you do not have to copy down, but this might help you understand what's going on. I'm going to do it in red. Now, you already know, no, you don't. A Grignard will attack this and kicks this out. So what you get these 2 compounds. Now this is a ketone. And notice I have 2 Grignards, and the second reaction, this reacts like you know, second step acid and water, and you'll get this alcohol. Now this is the conjugate base of an alcohol, strong base, and if I add acid and water, I'll get back my alcohol. And that's how you get the 2R triple primes on the same carbon. And that's how Grignard works. So let's have some fun with it. Oops. Oh, come on. There we go. Sometimes my pen doesn't want to change color. This is very easy ester to get your hands on. Almost forgot the 2 there. Now, what do we have here? What's different? Ooh, carbonyl with an oxygen, also that carbonyl carbon with carbons there, ester. And now, what happens when you react it with, what's this? Carbon, carbon, magnesium halide. Ooh, 2 Grignard. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. H plus is acid. I think by now you all know H2O is water, at least I hope so. And keep your eye on the carbonyl carbon. What's attached to that carbonyl carbon is still there, becomes an alcohol. And then you have your 2R triple primes from your Gringard, and this part of the ester becomes another alcohol. So let's take a look at this. What's our methyl? What's our prime? Methyl. What's our triple prime? And that's ethyl. So I have my carbonyl, which is no longer a carbonyl carbon. What's attached to it, our prime methyl. We'll have a hydroxyl group. And then I'll have my 2R triple prime, which in this case is ethyl. And then my R prime for my ester, the oxygen, becomes a second alcohol. And this is low molecular weight, and I can take that out, get rid of it easy. And look what you made. A very complex alcohol. Notice here you have a simple ester. This is a very simple Gringard to make, and you made a very complex molecule. And that's the beauty of Gringard reagents, especially reacting with ester. One thing I should mention, this reaction, I will never put a synthesis problem on test. And have fun. Samantha, I think your cat wants to help out. Oh no, does that make your cat organic now? See, she does want to help out. Okay, let's do it. Oh, is it Peaky? Ooh, I got good memory sometimes. Has she done this yet with her paw? All right, let's do it. What's different? We have, oxygen, double bond to carbon. Same carbon has oxygen with carbons on it, carbons here. We have an ester. What are we reacting it with? Carbon, carbon, carbon. Oop, the G fell off. Magnesium chloride. And there are 2 of them. That's a Gringard. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon, that's where the fun is. And you get 2 alcohols. The first one, you've made not 1, but 2 carbon-carbon single bonds. And from here, you get the second alcohol. And now if we go over here, what's our ethyl? What's our prime? Ethyl. What's our triple prime? And propyl. Just think about it. 6 months ago, If I said that, you wouldn't even know what I was talking about. See how much you've learned? I hope that feels good. And now we keep our eye on the carbonyl carbon, what's attached to it, and I'll draw it up here because I'm running out of room. 2 carbons. Then it will have a hydroxyl group because this carbon is this carbon down there. And then I'll have my 2 R triple prime. The carbon with the Gringard is a carbon bonded to this carbon. And come back in 5 minutes when I'm done putting hydrogens in. I'm just kidding. And you get a second alcohol from here. Our prime is ethyl. And that's how you do. Oh, let's do another one. These are fun. Your turn. All right, let's see, everybody's done, so I can get going. And what do we have here? Carbonyl, oxidized carbonyl, carbons here and here. We have an ester. Ooh, carbon, magnesium halide, 2 of them. We have not 1, but 2 Gringards. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it, R is still there. Has a hydroxyl group, you become an alcohol, and you make not 1, but 2 carbon-carbon single bonds, something very rare from the Gringard. You get a second alcohol, which is R prime from here. So if I come up here, here's my R group. Here's my R prime. And then here's my R triple prime. Keep your eye on this carbon. I'll write it over here, so I'm running out of room. What's attached to it? Ethyl. It'll have an alcohol. And what's R triple prime? Methyl. And then you'll get a second alcohol from R prime, which is ethyl. And there you go. And that's how you do reactions of a ester with 2 molecules or moles of a Gringard, second step, acid and water. And I've done this reaction in the lab. I've never used Gringard in industry, but I've done this when I was doing my research. All right, any questions? All right, seems like everybody's up to speed. Let's move on. Now, it turns out I've been sheltering you from some of the realities of life in organic chemistry. You can have more than 1 functional group in a molecule. And the following you don't have to write down that I'm going to be doing, but I did want you to learn something important. Now, if we look at right here at the screen, everybody see polymer esters? I'll have a whole chapter later on polymers, but poly means many, mer units, and a polymer is like a freight train with a lot of boxcars that are all the same and repeating. But in this case, instead of having couplers, you have functional groups, and one functional group is an ester. And therefore, you can have polyester. Ooh, that reminds me. Back when I was in college, I wasn't into it, but the disco craze was going nuts. And part of the clothing fashion then was polyester shirts and polyester sports jackets and polyester pants. Now, unlike cotton and other blended fabrics, polyester doesn't breathe. I'll teach you what that means. Doesn't hydrogen bond. And wearing that is like wearing a rubber sweatsuit. It's awful. Well, anyways, I think I was in high school or freshman year of college. Well, you needed a new suit and everything. And took me to where I got my suit and everything, all my clothing. Unfortunately, it's long gone. They used to have 5 stores, Hyman's Big and Men's Shop. You notice Dr. White's not tiny. And in fact, I got to know Gordon Hyman, the owner, and at the one in Skokie, where I used to go, he used to take care of all the Chicago Bears, a lot of them, and also many of the Archdiocese of Chicago senior priests, because they were overweight too. I guess it's good life for them. But anyways, she got me a polyester shirts, a jacket, pants, and I wore that thing whenever I'd be sweating, and oh, it was awful. And finally, it got out of style, and I got myself a new normal type suit and sports jacket and pants and everything. I didn't even give that to Goodwill. I'm not going to make other people suffer. That went right into the dumpster. Thank you. It's long gone and hated. Anyways, let's talk about polyesters. Now, if we look at the screen, you'll see terephthalic acid has not one, but 2 carboxylic acids. And again, switches off on this slide, but I want you to learn something. Here we have ethylene glycol. You learn has not 1, but 2 alcohols. And now I'm going to go to the whiteboard to show you something. You don't have to write this down. It's one of the few times I'll use a circle to get things quicker. Now, in real life, you use the acid chloride, but for this class, I use this acid catalyst. If I were to react this with acid catalyst, remember, here I have an ester, here I have an alcohol. And I'll make an ester. So if I have this carboxylic acid and this alcohol, what I'll get, and if something's not involved in the reaction, guess what? It's still there. And now I have this molecule that has an alcohol, an ester, and a carboxylic acid. Well, this one I can react with either more ethylene glycol or terephthalic acid. Let's do the terephthalic acid. And now, here I have a carboxylic acid, I have an alcohol, and what I'll get is this molecule. Now, if you look at the ends of this new molecule, I have a carboxylic acid, and I can react this. By the way, you'd also have H plus here, with more ethylene glycol. I also have acid catalyst. And what I'd get, say if I reacted this end, carboxylic acid, ethylene glycol. Again, you don't have to write this down. Whoops. Forgot something. No, that's better. And we have this molecule. Now, if we look at this, I have an alcohol here that can react with more terephthalic acid. I have a carboxylic acid here that can react with more ethylene glycol. And this, like the Energizer bunny, can keep going on and on and on till you put about 1,000,000 of each together. Now, if you were to look at this, there's a repeating unit. If I were to have it straightened out, you could see it better. But if we go back to the slide, here's the repeating unit. And this repeats over and over again. And N here, if you put enough of this terephthalic acid, ethylene glycol, would be large, like 1,000,000. So you can put a lot of them together. Now, let's look at the name of what I made. Now, it's an ester, and the R prime is called ethylene. CH2CH2 has got an organic chemistry, like you have methyl, that's called an ethylene group. And an ester, you drop the IC and the word acid. And for this one, and you add ATE. So this would be polyethylene terephthalate. Polyethylene terephthalate. Polyethylene terephthalate? Boy, that's thirsty work saying that long name. Polyethylene terephthalate. Oh, thirsty work. Nice water bottle. And if we go back and look at the screen, polyethylene terephthalate. Now I'm an organic chemist, I'm lazy. Let's call it PET. And that's the ester that my water bottle is made out of, is this ester. So if you're wondering why you're learning this stuff, why I learned that a carboxylic acid and alcohol can make an ester, all you gotta do is look at your popper water bottle. This is that polymer. It is thirsty work to say it all. But that's organic chemistry. By the way, the ink and label has something else, but that's another course. But seriously, next time you go in a supermarket, or if you have bottles like this at home, or your 2-liter or smaller pop bottles, that's all PET esters or polymers, polyethylene terephthalate. Now, there are other polyesters, and I'll talk more about that later in the semester. Oh no, we have finished the chapter. Guess what time it is? It's time for new functional groups. But before we get there, let's see. Next Monday, I will go through the ester and carboxylic acid problem set in class. a week from today. So make sure you start working on them, because test number 3 will be like test number 2. There'll be general knowledge. By the way, did you look at a bottle of vinegar and think of acetic acid? And there'll be nomenclature, 2 types. Here's a structure, give its IUPAC name. Here's its name, draw the structure. And then there'll be reactions. And it'll be same sort of point breakdown as test 2, but it will deal with different functional groups. All right, I have to warn you about something right now. The next chapter we're going to go into, if it looks like I'm having way too much fun, I am, because we're going to deal with a topic that I'm a world expert in, and I have 9 US patents in. I guess I know what I'm doing. And for many years, I worked for a company, international company, that made these type of functional groups. And I was in charge of all research for those functional groups in North America. Not bad. Actually, I also helped out with Brazil too, in South America. But I'm going to have a good time, and hopefully you will. All right, this chapter, we're going to talk about stuff that you'll be amazed at. One of them we'll talk about how do you get your clothes nice and soft and anti-staticky. It's something I've invented molecules to do that. Also, I'll talk about how to kill the germs in your mouth. Really? Yep. And then I have to admit I'll do it, but for you, I'll do it. All my students, I'll talk about one of the dumbest things I've ever done in my life and how I got out of a really, really dangerous situation by my knowledge of organic chemistry after doing something really, really dumb. And plus, this chapter is going to get nice and spicy near the end. And, ooh, I almost forgot. I'm going to talk about the dark side of organic chemistry, illegal drugs. No, I won't teach you how to make them, but we'll go over that too, and that's organic chemistry. So what's this new chapter? If you're reading the books, it's chapter 11 and 13. It's amines, amides, and heterocyclic compound. Now, let's talk about amines, and I work for a company, amines, and I know amines, they're one of my amines and their derivatives, things made from amines, are one of my other comfort functional groups. When I'm not feeling good, I think about them and it always cheers me up. But anyways, what's an amine? Well, let's take a look at ammonia. Ammonia is NH3. Now, an amine is where the hydrogens on the nitrogen are replaced with alkyl groups, cycloalkyl, which means rings, or aryl, benzene rings. Now, something important to mention. Unlike carbon, nitrogen has 5 valence electrons, and therefore normally it always needs 3 more electrons to get its octet, which I'll never ask on a test. So normally nitrogen has 3 bonds to it, like you see in ammonia. However, unlike carbon, which has 4 valence electrons, and all 4 can bond, and you need 4 bonds to carbon. That's why I'm always doing this. Nitrogen normally has 3. Let me go. So it needs 3 more bonds, valence electrons. However, the non-bonding pair of electrons and nitrogen, these can also bond. So nitrogen can have either 3 or 4 bonds, which some students find how should I say this, challenging, but I'll help you out. So nitrogen excuse me, can have 3 or 4 bonds to it. All right, this slide is off, but it says seaboard, I'll write it here. I'll use this terminology in class. If you replace one of the hydrogens, we call this a primary amine. I'll never ask this on test. If we replace 2 hydrogens, otherwise having 2 R groups, R and R prime on nitrogen, this is a secondary amine. Notice you have 3 hydrogens on nitrogen, ammonia. If I replace all of them, I have a tertiary amine. Now, one of the things I rarely do, but I'll do it now, remember, nitrogen has non-bonding electrons. And it turns out these electrons can be involved in a bond, but if they do, they're providing both carbons. Hold on, I'll slow up while you catch up. I tell you later in the semester, I'll talk about ketchup. Ooh, I should have talked about ketchup. Anybody pick up a bottle of ketchup and see it has vinegar in it, which is acetic acid? So when you look at a bottle of ketchup, that's organic chemistry. All right. I should warn you now, we're going into one of the most sacred areas of organic chemistry for Dr. White, because I've done a lot of good stuff here. That's quaternary ammonium salts. And here is where both of these non-bonding electrons are used in a bond. So now nitrogen has 4 bonds to it. Because it donated both electrons to this bond right here, it has a plus charge. And all molecules in nature have a net 0 charge. So if this is a positive cation, you need an anion. Now, I'm for this class just going to use the halogen anions, but it can be many other things, and I've used them. And here, X equals bromine, chlorine, or iodine. And this is called a quaternary ammonium salt. And Dr. White's going to try and be a good chemist and not revert into slang, because if you work in industry, we call them quats, which is short for quaternary ammonium salt, quats. But I won't say that again. I'll try and not use slang. But quaternary ammonium salts, I'll teach you later on, are very important in our daily life. If you like a fabric softener, it's in there, and certain mouthwashes, it's in there. It's amazing functional group. Dr. White loves quaternary ammonium salts. I've been good to them. They've been good to me. Real good. Now, good news. I'm not going to teach you the IUPAC nomenclature for amines, because most people, unless you're doing a patent or a contract, legal documents, use common names. And the common names are simple. For amines, you name the R groups on the nitrogen and add the word amine. I don't know why I don't put this in the slide, but if we were in a classroom for years now, I'd be writing this on the whiteboard. All right, so the common names for amines are name each R group as the alkyl group and add the word amine at the end. Let's take a look how you do this. Now, let's take a look at this molecule. And now, once again, look for what's different. What's not carbon, what's not hydrogen. Ooh, a nitrogen with carbons and hydrogens, the primary amine. But how would you name that? Well, this is an N-propyl group. And that would be N-propylamine. I'll do a couple more and then I'll let you have fun too. Now, I have to teach you something different we do for amines that we don't do for carbons. Notice I have the same group on nitrogen, methyl. So the name of this would be 2 methyls, dimethyl amine. Now, you've heard me talk all semester, organic chemists are lazy. This is one way of writing this, which I usually wouldn't do. Notice you have 2 methyl groups on the same carbon. So another way of writing the same molecule that you should be familiar with is this. These are identical. And notice this tells me I have 2 methyl groups on nitrogen. Why is there only 1 hydrogen? Because in an amine, at this point, you have 3 bonds to nitrogen. I already have 2, and therefore that's why I have 1 hydrogen. Your turn. What would be the common name? And on test number 3, for amines, I'll ask for common names. All right, looks like everybody's done. So I better get doing this. What's different? Nitrogen. Ooh, it's an amine. What's our R group? Isopropyl, so this would be isopropylamine. Oh, let's do another one. And why don't you try this one? There's 2 ways I could write it. This is one way, and the other way would be this way. Notice I already have 3 bonds to nitrogen, so that's why it doesn't have hydrogen. All right, looks like everybody's done. Let's take a look at this. What do we have? Oh, we have a nitrogen, and it's got 3 groups on tertiary amine, but you don't have to know that. Notice 2 are the same. So one way of doing this would be dimethyl Then what's this? Ethyl amine. Ah, that's the ugliest looking. M. However, this is common name, so there's no rule. I could also call it ethyl dimethyl amine. And that's how you do common names. Well, let's do one more. And you should know how to draw a structure from a common name. If I had I'll let you try this. Why don't you draw diisopropylamine? All right. By the way, say hello to my old friend diisopropylamine. When I was in graduate school, this was a very important molecule I used in my research, because I used that, or derivative of that, to do certain reactions I was investigating. All right, di means two, isopropyl. We have a nitrogen, and this would have a hydrogen. This is one way of drawing this. Or you could have drawn it this way. Since your instructor knows amines, either way would be correct. Now, let's look at quaternary ammonium salts. One of these days, I'll have a slide, but if we were in the classroom, I'd be writing this on the board. Maybe next year. Name each R group. Ah. And then at the end, the words ammonium halide. And let me just tell you, if it's chlorine, chlorine minus, it's chloride. If it's bromine minus, it's bromide. If it's iodine minus, it's iodide. And that's how you do quaternary ammonium salts. Now, let me just point one thing out about quaternary ammonium salts. Convention, you put the anion to the right of the last R group. This is not bonded to that, it's ionically bonded to nitrogen. So technically there are 5 bonds to nitrogen, 4 covalent and 1 ionic, but we usually just look at the covalent. We're talking about 4 bonds to nitrogen. And we look at the following. What's this common name? I'll do this one. Oh, look, nitrogen with a plus charge and a chloride anion. It has 2 4 bonds, so this is a quad. Quaternary ammonium salt, bad, Dr. White. And here, what do I have on there? I have a dimethyl. There are 2 methyl groups. Notice I have 2 ethyl, diethyl, ammonium. And what's my halogen chloride? So I can put down chloride. And I'm done. Remember, 2 is di, 3 is tri. And what would be the common name of this molecule? All right, looks like everybody's done. Oh, look, nitrogen, but it's got a positive charge, and you have a halogen anion. This is a quaternary ammonium salt. And this would be trimethyl. What do I have here? 3 carbons and carbon attached to the nitrogen, and propyl. Ammonium, and bromine would be a bromide anion. And that's how you do it. Now, I would like to introduce you to a very special quaternary ammonium salt, one that paid my mortgage and other things for many years and got me around the world too. Now, R sub T is tallow. And when we get into fats and oils, and this is a tallow alcohol, or just call it tallow group, that means it has 16 to 18 carbons with and without a double bond, a mixture. And therefore, what is this called? Ditallow. because there are two of them, dimethyl ammonium chloride. And why is this molecule very important? Because for many, many years, until about 10, 15 years ago, this molecule, dimethyl ammonium chloride, was the only molecule used for fabric softener. Then they found a cheaper R group, it's called an Ester quad, which I won't be teaching, and now that is. But all your fabric softeners, whether a sheet or you add it to your washing machine, are quaternary ammonium salts. Now, a couple things. How many of you have had older towels, like for your bathroom, and they no longer work that well? And you say, oh, I got to throw them out. No, you don't. What happens is the quaternary ammonium salts, they use a fabric softener, covered the fabric enough that it doesn't work while absorbing water. How do you repair that? You wash them once or twice and dry them without a fabric softener. That's called re-wet, how well it absorbs water, the scenario Dr. White's worked in, and that gets your towels back to normal. Do I have time? Yes, I do. Time for Dr. White's story. Now, I was in charge of all quaternary ammonium synthesis and manufacturing from the R&D, research and development, for all North America for what was then called AkzoNobel. And I worked for a company, and we bought from another company, and their raw materials that we bought were giving us trouble. And the president of the company asked me, can you straighten this out with that other company? By then I already had a reputation as a problem solver. Well, I found out what the problem was, and I taught this other company, who was called Unichem Chemicals, that, hey, here's your problem, here's how you fix it. So that way we won't have any headaches, which makes my life a lot easier. I'm not going to get a call in the middle of the night, we're having this problem. And I would get those calls. So the people at that other company were so impressed that they offered me a job and made me an offer I couldn't refuse. They doubled my salary. But back with quaternary ammonium salts, when I went to this other company, which Unichem was part of Unilever, this is my level in the company, I'd go to Europe to senior manager meetings. And one time I was in Europe, I'd just been with the company for a while, but I already made a reputation by solving a couple of problems that nobody else could. This is now at Unichem. What you don't know, but I'll tell you, it's a secret. Chemists know how to party hard, especially on company money. We'd have meetings all day, and at night we go to a local pub in England and drink. And the company paid for that. It happens everywhere in chemical companies. Anyways, I'm at this meeting, and we're at a nice old pub, you know, something that's been there since 1800s. So we're drinking. And one of the colleagues of mine said, "Ooh, there's the vice president of research development for all of Unilever. Go over and ask him about the Snuggle Bear." What? He said, go ask him about it. And I'm not afraid to talk to anybody. I go over. I said, I've been told you have a good story about Snuggle Bear. And he smiled. Not Snuggle, Downy, I'm sorry. No, Snuggle. I was right. I always get it mixed up. But anyways, Snuggle. Now, if you go and buy Snuggle, you see a nice little teddy bear on there. Well, when they first came out with that product and were about to go worldwide, the marketing people said, we need some sort of logo or mascot. And they had a big competition inside the company. Anybody did it got a lot of money. I think it was $10,000 or $25,000 if they used your idea. That's a lot of money, but in the long run, it's cheaper than going out to outside company and have them develop it. I know one company did that and they had to shell out like $300,000. Anyways, one day the research director, he's telling me the story, and I found out from other people it's true, was about to leave, and he had his 3-year-old son who was holding this old beat up teddy bear. And he was going to kiss his son goodbye, go to work. And he said, "Can I borrow your teddy bear?" No. Well, I don't know. The way he told it is he made his son offer he couldn't refuse, bribed him. "I'll borrow your teddy bear for a couple of days, but you'll get it back." He brought up this old beat up teddy bear. "Here's your mascot," and you know the rest. And that's my story. And it's amazing some of the things I've been involved in. There are different chemical companies that are true. But we had some fun times in, where were we? Oh, that meeting was at a small resort inn and bar in outside of Manchester, I think it was. And the name of it was The Last Drop Inn. And if you've ever seen on pictures from England or been there, the old pubs and everything had outside a wooden sign with some sort of picture. And you know what The Last Drop Inn was named after? They had a guy being hung, the last drop. And that's what they had on their wooden board hanging outside their inn, with someone being hung. Interesting. But anyways, I think it's time for a break now that I totally shocked you with another Dr. White story, and that's true. I wonder if they're still in business. I'll have to look on the internet later today. But anyways, come back at 5. Let's see, it's approximately, I'll give you an extra couple minutes because I need it for my back. Come back at 2:55. That gives you a couple extra minutes. I can go check my mail too. I'll see you in a couple. All right, let's get started so you all can get out early today. All right, I was talking about quaternary ammonium salts, and here we have tallow, dimethyl ammonium chloride, or other quaternary ammonium salts. Now, when you have a quaternary ammonium salt, and the switch is off on this, and here, if our groups are C8 to C10 carbons, these are very good antimicrobial compounds that are used to disinfect certain operating rooms and other things. You can't really take them because they're not good for your health, but they kill viruses and other things, antimicrobial compounds. And if I've looked into it, certain quaternary ammonium salts are being used now for disinfectants for COVID-19. So interesting how these are used very wide area in terms of many different applications, quaternary ammonium salts. And, ooh, hold on. Don't go away. Thank you for not going away. Now, unfortunately, in my family, it's hereditary through my mother and my grandparents on her side. And guess what came to me and my sister? We have dental problems in our family. It's just hereditary. But anyways, that's just life. Now, many years ago, I was having a problem with my gums. I had a great dentist. He's since passed away. I wish he had, and he was great. But I was having problems with my gums. He said, use this mouthwash. And it was prescription, and there was no copay. And a bottle about this big, about 700 milliliters, about the size of this, costs about $70. It lasts about a month and a half or 2 months. And it killed the germs and all the problems in my gums, so they're nice and healthy. But the other thing is, if you didn't brush your teeth real good, it turned them brown. Well, anyways, I no longer went to him because he passed away, like I said. I hadn't found a new dentist yet, and I was almost out of that mouthwash. And I said, all right, I should be able to go to the supermarket and get a mouthwash that's antimicrobial. And there are two types, Scope and Listerine. I bought some Listerine and, oh, ouch, it hurts. It wasn't helping my gums. So I looked at the label, looked at Listerine, and Listerine uses as an antimicrobial a phenolic compound, a benzene ring with a hydroxyl group and an R group on it. And that wasn't doing anything. I figured, all right, two types, Scope. I looked at the Scope label. By the way, it's cheaper if you buy it from Walmart. Same thing. And you'll see, I don't know if you can see the label right here. At the very end, just about, it has cetyl pyridinium chloride, which is another common name I'm not teaching you. And what is that? It's a quaternary ammonium salt. And I should, and by using that, all of a sudden, it's gone. No gum problem. If I had gum problems, I'd do it like this, I'd be in severe pain. Nope, not in severe pain. So this stuff is a lot cheaper than $70 a bottle, smaller bottle. If you get it at Walmart, not that I get any kickbacks, it's the same as Scope. Look at the labels, they're identical. Walmart, one thing they are is in their house brands, they're very ethical. They make a good product. And it's half the price of Scope. So it's a good deal. Plus, I'm there. Now, what's pyridinium chloride? Acetyl pyridinium chloride. I'll teach you later on. Pyridine is what we call a heterocyclic. We're a 6-membered ring where one of the carbons has switches off for this, by the way. And our group, cetyl, C12, and this is a quaternary ammonium salt. And this is antimicrobial in my mouth. It's safe enough, I can put it in there. But on the bottle, they say don't swallow it or go immediately to emergency room because it's not good for you to consume. But this kills the bacteria or germs or whatever in my mouth, so my gums are nice and healthy. Oh, one other story real quick. Ooh, this is story time. If you go, you can find fabric softeners that are liquid and fabric softeners on the dryer sheets. Dryer sheets are much better. I work for the company that sold the quaternary ammonium salt that are used in fabric softeners like for Procter & Gamble and also for Unilever, Snuggle and Downy. The fabric sheets are much better. Both companies told me that. Now, time for another story. Now, when Procter & Gamble first came out with Downy, they were the first with the dryer sheets. Any large company that's going to roll out a new product, their marketing sales, do research, see what kind of sales they should have the first year, each quarter. And generally, those numbers are pretty close if they have a good marketing sales group. And Procter & Gamble has a good one. Because I work closely with them, not today, but Wednesday, somebody reminded me to tell the odor story about with Procter & Gamble. But anyways, I got to know people there, and they told me an interesting story. When they first came out with the dryer sheets, their sales was half what they expected. Yes, half. And that got upper management quite upset. So they did some research. One of the things I've learned working with Unilever and Procter & Gamble in the United States called Lever Brothers, those companies and many others have the most profound respect for the American housewife and outside the United States for the housewife. And why were their sales half of what they should be? Because the first product they issued, there was so much quaternary ammonium salt on those sheets you put in your dryer. The housewives figured out, guess what? I can save it and use it a second time, which is why their sales were in half. Guess what they did? They cut back way on the quaternary ammonium salt in the sheet so you could only use it once. And their sales got up to the level double. And that's a true story. So the housewife is quite smart. All right, just the switch is off here. I just thought I'd show you why most people don't use the IU pack. Let's look at the following molecule, and the switch is totally off. Come on. Why aren't you? Hold on one second. There we go. Once in a while, Zoom messes up computers. And now I lost my train of thought. Oh, now I remember what I was doing. Now, switch is totally off for IUPAC for amines, primary, secondary, tertiary, similar to alcohols, except you use amine, drop the E, add amine instead of OL like an alcohol. Now, unlike alcohols or carbon, you can have secondary and tertiary amines. And you notice whenever I wrote N-propyl or N-butyl, I use the lowercase n. That's because for amines, the capital M tells you when there's a substituent on the nitrogen. And let's go through this. I was about to do this. Oh. Now, IUPAC, you find the longest chain of the alkyl groups, and the name is an alkane. And that'd be butane. Drop the E, add amine. You don't have to write this down because this will never be on test or final. What carbon is nitrogen on? It's 1-butanamine. And then here I have my smaller one, and that's a methyl. And how do I say it's on the nitrogen? Capital N, N-methyl 1-butanamine. Otherwise, the common name would be N-butyl methylamine, which is easier to write and do. And that's how you do nomenclature of amines. But did I give you any practice problems? Yes, I did. Let's do one other thing. Why don't you draw the structure for this compound, diethylamine? While you're doing that, I'm gonna put my mouthwash back in my bathroom. I remember I haven't said it in a long time. If you ever have any questions, ask, because in my class, there's no such thing as a dumb question. All right, looks like everybody's done. What do we have? If we go this way, an amine, I have diethyl, ethyl. Now you could have written it this way. Remember, 3 bonds to nitrogen, or you could have also written it this way. And let's do one more. And why don't you draw the structure for trimethylammonium bromide? All right, it looks like everybody's done. Let's do this. Start from the right, move this way. Ammonium bromide. Well, quaternary ammonium salt. And what are my R groups? Ethyl and 3-methyl. Now, you don't have to put the charges there, but I do. That's one way of writing it. And another way, which would be also perfectly correct. It doesn't matter which side has the ethyl. Oops. And that's how you do it. And that's how you do quaternary ammonium salts. Now, switches off. When we talk about amines, the smaller amines have a strong ammonia odor, and they're liquids and solids because a nitrogen with a hydrogen on it can hydrogen bond. And therefore, your larger amines are liquids and solids at room temperature. Now, how do you make an amine? Let's go through the first slide. This slide is a little busy, and I'll rewrite it on the whiteboard, this one right here. Let me rewrite it. By the way, switches on. Now, to make primary amines, and this is how you draw primary amines, just like you saw with primary alcohols. If I take ammonia, NH3, plus an alkyl halide, in the presence of base, like sodium bicarbonate or sodium carbonate, because you generate HCl or HX. Remember, X can be bromine, chlorine, or iodine. The non-bonding pair of electrons are what we call a nucleophile. If you have a carbon with a halogen on it, this is slightly positive, this is slightly negative, because this is more electronegative and shares the electrons closer here. Well, if you're a nucleophile, you're going to say, ooh, I'm going to attack you. And yes, organic chemists use that. And this nitrogen attacks the carbon with the halogen. You lose the X and H, you get X acid, but I'm only interested in the organic molecules you make, and you make a primary amine. And the carbon with the halogen is the carbon that nitrogen will be bonded to. Now, if we look at this, what do we have? Ammonia, what's different? You still do that. Ooh, carbon with a halogen. This is ammonia plus an alkyl halide with some base. And what you get is a primary amine. Remember, amines, primary, secondary, tertiary, have 3 bonds to it. And just like you knew with how many hydrogens in carbon, that's why I only have this. What's my R group? Isopropyl. Do you break carbon-carbon single bonds? No. And I've made this amine. It doesn't matter what you put first because you're mixing it too. And I'll let you have some fun too. Your turn. Oh, who's behind you?
That's my mom.
Hi, Mama Samantha. Bye, Mama Samantha.
Oh, that's fine.
Are you done?
Yeah, I'm done now.
Okay. I won't even charge you extra if she wants to watch too. All right, let's take a look at this. What's the organic product or product? 3 points each. What's different here? Ooh, carbon with a halogen, alkyl halide. Ooh, ammonia. Base. You form a primary amine. And what's my R group? These 4 carbons. What carbon has the halogen? We'll have the, well, this should be a 2, sorry about that. And here we have 4 carbons because you don't break carbon. The N carbon has the halogen. And that's how you do it. Oh, let's have some more fun. On test number 3, like test 2, I'll have 3 or 4 synthesis problems. And why don't you try, what do you react with ammonia to make this compound? That's a cyclohexane ring, not a benzene ring. All right, if we look at this, what's different? Ooh, nitrogen on a carbon. This is a primary amine. What do we react with base and ammonia to make that? An alkyl halide, where X is chlorine, bromine, or iodine. Now, since I don't tell you what acid you'd be neutralizing, you can use any of these as X. So in this case, what's my R group? The ring. And therefore, and it doesn't matter which carbon you put the halogen because they're all the same, but I have used iodine. You could have just as easily put chlorine or bromine there. And that's how you do primary amines. Now, remember, it's the non-bonding pair of electrons doing what's called the nucleophilic attack on the carbon with the halogen. Well, what does that mean? If we look at the primary amine, it still has non-bonding electrons, which are nucleophilic. And if I take a primary amine now and react with different or the same alkyl halide in the presence of base, I'll make a secondary amine. Let me rewrite on the whiteboard. If you take a primary amine, the non-bonding electrons will attack the carbon with the halogen bond to that. This is a carbon-nitrogen bond, which is quite easy to make, more prevalent than carbon-carbon single bonds, which are very rare, hard to make. And you lose a hydrogen X, and it's neutralized by the base. And what you get, it doesn't matter which side the nitrogen, the R and R prime are. Now, if we look here, what's different? Ooh, a nitrogen with a carbon and a amine. Carbon-carbon halogen, alkyl halide. By the way, I forgot to put here, but you already know X can be chlorine, bromine, or iodine. And the carbon with the halogen is bonded to nitrogen. Oops. This doesn't want to. That should be an ethyl group. All right, your turn. Hold on one second. Let me try one thing. All right. Okay. All right, do you see the whiteboard now? Let's try something. Yep, I got it working. For some reason, when I have too many things right now on this computer, I've got about 4 different programs running. They're all memory intensive, CPU intensive. All right, let me have you have some fun. And the question is, what would be the organic product or product for a following reaction? And when you're all done, give me a thumbs up, all of you. All right, let's take a look at this reaction. What's different? Ooh, nitrogen with carbons. This is a primary amine. Then carbon, ooh, halogen on a carbon and alkyl halide in the presence of base. The lone pair electrons attack the carbon with the halogen, kick it out, and you form a secondary amine. This is my R group. This is my R prime. My R group, nitrogen, 1 hydrogen. And which carbon has the halogen? The center one, this one. So this will be bonded. This is one way of drawing it. There are other ways you could do it too. and you'd make ethyl isopropylamine. And I'd ask you to try this one. What two things would I react to make that molecule? For those of you watching the video, make sure you do these problems, just don't watch it. All right, looks like it. Hold on, let me check. I think everybody's done. So what's different here? Remember, when you look at a molecule, look for what's not carbon, what's not hydrogen, and that will tell you exactly where the fund's going to be. Nitrogen with 2 carbons or chains on it, and this is a secondary amine. How do you make a secondary amine? You react a primary amine plus an alkyl halide. Remember, X can be chlorine, bromine, or iodine. By the way, this is synthesis. It's the fun part of organic chemistry. And one of these I'll call R prime, the other I'll call R. And therefore, if that's true, R is methyl. So this would be my amine. That should be a 2. And my R prime is methyl. And pick whatever chlorine, bromine, or iodine. I'll do chlorine now. And these two things, well, yes, make that molecule. And that's how you make secondary amines. Now, if you notice what happened here, I usually don't draw it in, the non-bonding electrons attack the carbon with the halogen. Well, in a secondary amine, we still have non-bonding electrons. And guess what? They can attack, wrong one, right one. And if you have a secondary amine reacted with an alkyl halide and base, you'll make a tertiary amine. And let's take a look at this. Thumbs up, people. Can you see the whiteboard? I see you all raised your thumb. Thank you. All right. And if we were trying to find what's the product or products for the following reaction, let's take a look at what we have. Ooh, nitrogen, look for, and it's got 2 alkyl groups. So we have a secondary amine. Carbon, carbon, ooh, halogen, alkyl halide. The presence of base will make a tertiary amine. Notice there's no hydrogens because in this molecule, 3 bonds to nitrogen, it has it, therefore it doesn't need any hydrogens. What's R and R prime? Methyl. What's R double prime? Ethyl. And therefore, I can write it 2 ways. Like this, or which most of you probably would do, which is also perfectly correct. Like that. And that's how you react. Remember, the non-bonding electrons will attack the the carbon with the halogen. I got carbonyl of the brain. And let me have you try one. And your turn, have fun. And take your time. I give everybody plenty of time to finish, so don't rush. If you finish early, please be patient so everybody can finish. All right, I think you're all done. Let's take a look at this. What do we have? Ooh, a nitrogen. Remember, look for what's not carbon, look for what's not hydrogen. I got a nitrogen with 1, 2 R groups, secondary amine. This molecule, carbon, ooh, halogen, alkyl halide. In the presence of base, it doesn't matter which side R prime and R double prime are, I'll get a tertiary amine. One of these I can call R, doesn't matter which you do. The other R prime, if you switch them, that's okay. Then over here, I have R double prime. This is R prime, sorry about that. And therefore, on my nitrogen, I'll have a methyl, an ethyl from my original secondary amine, and then I'll have another ethyl group. Now, this is one way of writing the molecule. Another way, since I have 2 ethyl groups, I can use this parentheses, and also I have a methyl group. And that's it. Oh, we got to do another one. Let's have fun. Did I fill up all? Oh, all right. And have some fun. What would be the product or organic product or products of the following reaction? All right, let's take a look at this. What do we have here? Ooh, cyclohexane, that's not, ooh, a nitrogen with 2 R groups, a secondary amine. Carbon, ooh, halogen, alkyl halide. in the presence of base, remember X here can be, which it is chlorine, or it could have been bromine or iodine. This attacks that. And you make a tertiary amine. One of these I call R. Here I could call this R prime. And this methyl group is R double prime. And one way of drawing this molecule would be this way. And I could have also drawn it this way. And this is the molecule. And this would be dimethyl cyclohexylamine. I haven't talked about it, but we call that a cyclohexyl group. Now, one of the things I've been asked to do more and more is ask the question, why am I learning this stuff? And the obvious answer is you want a good grade so you can get into a program or school that told you got to take organic chemistry. Not with Dr. White, but take organic chemistry one semester. But why are you learning this? Let's look at the reaction you just did. Now, if you look at this reaction, this new molecule right here has a trade name. Notice it has 8 carbons, 6 plus 2 more, and it's called polycat 8. And it's made by, I think Air Products bought out the company that used to make it. Poly means polymer, cat, short for catalyst, 8 carbons. And this molecule, which you just learned how to make, is used as a catalyst to make something I'll teach you later on, urethane foam. Now, if you're sitting on a chair that has a nice cushion, that's urethane foam. And they use this molecule to make that. If you have a couch or you sit in your car, it's used. It's also used to make the insulation in your refrigerator. So, why are you learning this stuff? Well, it's being used to make things you need or like. I don't know about you, but I'm glad when I sit in my car, I'm not sitting on a bare piece of wood or metal. It's soft, it's comfortable. And that's because I've got a bucket seats in my SUV. I have an Explorer. Oh my goodness, I just looked at the clock. We're out of time. Boy, time flies when you're having fun with organic chemistry. I'm going to ask one of you, please stay after class. I need to talk to you. But I think I'm going to have to do my favorite. It's time to say goodbye. I hope you had a good day learning some organic chemistry with your host, Dr. White. I'm going to say, gang gesund, be healthy, goodbye. And at that, I'm signing off. Bye now.